Everything we have built so far lives in one file. The parameter, variable, storage account, conditions, all crammed into main.bicep. And it works. But the moment you need same storage setup in different projects, you are now copy pasting the whole thing and hoping you don't miss a line. That's not reusable, that's really fragile. Hi there, welcome back to Azure Bicep from scratch. And this is episode number 4, and if you're not subscribed to the channel, please bump the subscribe button and come join my learning community. So today we are breaking things apart and we're going to take our storage account, pull it out into its own module, and then add a second module for a web app. And here's the part that makes it interesting. The web app is going to receive storage endpoint from the storage module. The modules talking to each other. And by the end of this video, your project is going to look like a real infrastructure code base, clean, organized, and actually reusable across projects. Alright, let's get into it. So before we start moving code around, let me explain what the modules actually is. Because the word sounds more complicated than it is. A module is simply a .bicep file that you can call from another .bicep file. It has its own parameters, its own resources, and its own output. Think of it like as a function. You pass in some input, it does a thing, it gives you back some output. It's the same concept. So you end up with this structure where your main bicep file is the orchestrator. It doesn't have the resource in it directly. Instead, it calls the module to deploy the resource. Each module itself is responsible for one piece of your infrastructure. Storage in one file, web app in another, networking in one. And the keyword you use in the bicep to call module is literally just the module. Now here's what most people get wrong. They think module are some special construct you have to register somewhere or configure, and they are not. A module is any .bicep file, a file that you have been writing this entire series. That could be someone else's module right now, and there's nothing special about it. Any .bicep file can be called as module from another bicep. So here's our main .bicep file from last episode. What we got is our parameters up top, the variables, the conditions, and down here we have the storage account resource. First thing I'm going to do is create a folder called modules inside this directory. And inside that folder, I'm going to create a new file called storage.bicep. Now here's what I'm going to do with this. I'm going to move the storage account resource out of the main.bicep file and inside this new file. Since I can't just copy paste stuff directly because resources need parameters that all live in main.bicep file. So what I'll need is my own parameter inside this module. Let me start with the parameters this module needs. The location, and finally the SKU. So the module takes a name, location, and the SKU with a default. And these are the inputs here. Now I'll need to update the storage account resource to match these naming variables. For that, I'm just going to copy paste this new block of code and do this. So what we have is a storage account is already using a location, and we have this queue defined up top, which is going to be picked up. Now the last piece is the output. If another module or main file needs something from this storage account, most likely the resource ID or the blob endpoint, I need to output those values. Alright, so that's the module. It's self-contained .bicep file. It takes input, create a resource, and expose outputs. Now, let's go back to the main.bicep file and replace the storage account with the module call. I'll delete all the old resources and just replace it with this new block of code, which is module storage. If I can type. So let's break this down. The keyword is module. Then I give it a symbolic name, such as storage in this case. It's the same idea as naming any resource block. Then the path to .bicep file, which is the storage.bicep file inside the modules folder. And finally, the name property, which is the actual name of the resource deployment you want to show up in Azure. And then we just follow simply with the parameters, simply map to the parameters that we defined inside the module file itself. Let me deploy this and make sure it works. And before I do that, I'm just gonna clean up some of the items that I don't need. I'll run az deployment group create. Let's run this command once more. Since I don't have the resource group already deployed, I'm just gonna go ahead and create our resource group here. It's called rg bicep demo. Doesn't matter which location I pick. With that in place, let's run through the deployment again. All right, so deployment is finished here. Let me look inside the resource group real quick. And we have our storage account just as before. The same logic, same result as before, but storage account has been deployed now with code being more organized inside a single file. So now if I need a storage account in a different project, I just copy that one file. All right, so now we know the pattern. Let's add the second module. We are going to create a web application. I'm going to call this file webapp.bicep. What we need is an app service plan and a web application resource. And we're going to pass a storage account endpoint from our storage module into this web application module. This is where things get interesting because now a module is talking to another module. Let me start with the parameters. Notice the third parameter, storage endpoint. This is going to come from the output of our storage module. The web app doesn't really know where the value comes from. It just receives it as a parameter. So there's a clean separation between the web application resource and the storage account resource. Now, if you're using any IntelliSense or GitHub Copilot or Claude, you may get some of the recommendations on what that service block is going to look like. So I'm just going to discard this for now, but you're more than welcome to take the recommendation. What I'll do is provision this app service plan first of all with the name dash plan. We are just using the freeze queue for now, so you don't need to have any standard or dynamic queues. The kind is really important. Make sure it's Linux, and if you do define the Linux, make sure it's always reserved true, otherwise the deployment will fail. The second resource we need in this piece is the actual web application, which is the web app, which is of type microsoft.web/site. We need the location and the name. Following that, we also need the server farm ID, which is the app service plan ID itself. And in the end, we have the app settings. This is the environment variables on the application itself. And what we're going to test for is a storage endpoint and the value that comes from the parameter. Now, let me also add the output here so we can navigate to the web app once the deployment finishes. So I'm going to do this HTTPS format just because the default host name doesn't come with any protocol. So we want to have any HTTP or HTTPS depending on your setup. Now this is done. Let me go back to the main.bicep and let's wire these two together. I'm going to call a module again, and this time it's a web application module. So I'll give the path. And you can see IntelliSense is already giving me a lot of help here, but I'm just gonna continue typing. And let's just make sure we have the name called web app. This really doesn't matter, it's just an application name. Make sure it's a unique name across the global environment. Okay, I'll do the app and then I'll just put this unique suffix and finally end with the demo. Now, as you can see, the storage endpoint is actually coming from storage module and the output of that module and a value called endpoint. If I go back to the storage account real quick, you can see we do have an endpoint output. So that's what's going to be used here. So finally, to get the output on the main bicep file, I'll need the output defined on this level. So I'll do string, and then in this case, I'm going to target the web app, the output coming from that module, and the value of the URL, which is this here. I'll go back, save all of this, and I'm going to run the deployment once more. Just with everything as we did before, you don't need any change in the deployment command itself. Alright, the deployment has finished. What we're looking for is the output value of the web application. So what I'm looking for is the outputs block, and what we have is the web app URL. This is the application URL we got. Let's navigate to the app itself. Since this is a demo application, there won't be anything much on this one. What I do want to find out is what's going on the application resource itself. We just passed the storage endpoint, and we want to make sure that value actually appeared and ended up on this page. I'm going to click on the advanced edits to see all the values. We have here is the storage endpoint, which is stcw, and if we go take a look at our storage resource itself, that's probably what we were looking at as stcw. So the output from the storage module came to the main, which was further passed down to the web app module and used inside the web application module. That's two modules working together. Let's take a step back and look what we have built. The main.bicep file in the root is the orchestrator, the dev and prod parameter files next to it, and the module folder with storage.bicep and webapp.bicep. That is the structure I use on every project. The main file orchestrate, it calls the module, wires them together, and each module is self-contained. It has its own parameters, its own resources, and its own output. If your team has a standard storage configuration setup, encryption settings, network rules, access policy, you put all of that in a storage module. Now every project that needs storage, just call the module with the right parameters. You have one place to update, and everywhere it's used, get that change. I worked on projects where main.bicep file call 15 modules, networking, DNS, web app services, SQL, all separate modules, and all of them wired together in one main.bicep. And when the security team updates a TLS requirements across different storage accounts, they change just one file. And that's just one module change, and every project that refers it got the new update on the next deployment. And that's the payoff. Now for bigger team and bigger project, there's actually a thing called Bicep Registry where you can publish modules and version them. Think of it like as a package manager for your infrastructure as code. We are not going to dive into that today, but that's a topic on its own. But I wanted to let you know that it exists because it builds directly on what we just learned. Alright, quick recap. We took monolithic main.bicep file, broke it down into modules, and wired those modules together with output and parameters. The project is now organized, reusable, and actually maintainable. In the next episode, we are stepping it up. We are going to use loops, so you don't have to copy paste resource blocks, dependencies, so things deploy in the right order, and what if command that previews exactly what Azure will create before you deploy. That what if command is super important. It's the are you sure check before you change production infrastructure. If you're not subscribed to the channel, please bump the subscribe button and come join my learning community, and I will see you in the next one.